Hi everyone, welcome back to the channel. Today we are learning one of the most fundamental algorithms in machine learning, that is the decision tree. Now let's start our video. So what is decision tree? It's a supervised machine learning algorithm and it is a flow chart like model which makes decision step by step. And at the end of each path there is either a decision or a prediction. Let's see its example. Imagine a scenario where we are deciding whether to play outside or not. So first we might ask, is it raining? If yes, then stay inside. If no, then we may check another condition like temperature. So if temperature is greater than 24 degree, then play outside. Otherwise, stay inside. Therefore, this is how a decision tree works, by asking questions and splitting the data step by step. Decision tree structure. A decision tree is like a flow chart used to make decisions. There are different parts to it. We have root node. This is the topmost node of the tree and is the starting point, and it represents entire dataset. Decision node. These are the decision points inside the tree, and each node tests a condition such as age is greater than 20 or study hours is greater than 40, something like that. And based on the test, the data is split into different branches. Branches. A branch represents the outcome of test. It connects one node to another node. Leaf nodes. They are the endpoints of the tree, and a leaf node gives the final prediction or a decision. How does a decision tree work? The first step is to define the problem. For example, we want to predict will a person buy a car or not. We have data such as income level and credit score. Let's start with the root node. At first, the algorithm looks all the features and decide which one to split. Suppose if the best feature is income level, then root node equals to income level. Then let's create branches from the root node. From the income level feature, we can branch into high income, low income and medium income. If high, then a person will buy a car. If there is a low income, then he or she will not buy a car. But if the income is in the medium range, then we need to check another factor, that is credit score. It will be like a person will buy a car if there is a medium income and good credit score. Otherwise, he or she cannot buy a car. At the end of every branch, we get a final decision in leaf node. High income, yes to buy a car. Low income, no. Medium income plus good credit, then yes. And medium income plus bad credit, then the result is no. So this is how a decision tree works like. Let's see the tree with a real example. We have data such as a person with income equals to medium and credit score good. Then the tree will check if income is medium, then go to the credit score branch. If the credit is good, then the final decision, that is to buy a car. Therefore, the tree keeps splitting the data step by step until it reaches a clear decision. Entropy. It measures uncertainty and randomness in the data. The higher the entropy, more the information content. And the formula to calculate entropy is like this. Here P1 and P2 are the probabilities of classes. When a dataset has all the same outcomes or belong to one class, then the entropy is 0, which means pure. That is, there is no uncertainty left in predicting the outcome. Similarly, if the outcomes are evenly splitted or equal number of yes and no, then the entropy is 1 or high, because we don't know which outcome to predict as it is uncertain. The example is like tossing a coin. We can get probability of tails like 0.5 or the probability of heads 0.5, and then if we calculate entropy in this case, it is equal to 1. Hence, there is a maximum uncertainty as we cannot predict when it is head or tail. But if we have 90% head or 10% tails, then at that time the entropy calculation equals to 0.469, which means it is less uncertain to predict than the ordinary case. Information gain. Information gain let us know how much entropy is reduced after a split. The formula to calculate information gain is like this. Here, yes is the original dataset, A is the feature, SV is the subset after splitting. So we calculate information gain for each feature, and to split we pick the feature with the highest information gain. Let's see an example of information gain. Suppose we have 10 students and 6 are passed and 4 are failed. Therefore, entropy before the split can be calculated like this, and it is 0.97. Now, if we split on study hours, we can group like Group 1 and Group 2. Group 1 is a student who study more than 5 hours, and in that group we have 5 pass and 1 fail, and its entropy calculation is 0.65. Similarly, Group 2 has the entropy as 0.81, and the weighted entropy after the split is 0.71. Therefore, the information gain is 0.97 minus 0.71, that is 0.26. So this tells us study hours is a good feature to split on. Let's see another example. Our data set is to play tennis based on the weather. So this is our data. We have total samples 8, and we have here 5 yes and 3 no. And if we calculate the entropy, then entropy equals to 0.95. Now if we split by the weather, for sunny we have 3 samples, 2 no and 1 yes. Therefore the entropy will be 0.92. And for cloudy there are 2 samples, both are S, then the entropy is 0. And for rain there are 3 samples, 2 S and 1 no, and the entropy calculation is 0.92. So if we calculate the total entropy, then it is equal to 0.69. Therefore, the information gain is 0.95 minus 0.69, that is 0.26. Hence, the weather is a good splitting feature. Advantages: it works for the classification and regression. It's easy to understand and visualize. It handles both categorical and numerical data. Disadvantages: it is biased towards features with more labels such as ID numbers, unstable. That means small changes can alter tree drastically. That's all for today. Thank you for watching. If you like this video, do not forget to like, share and subscribe my channel. See you in the next video.